All right, lesson 9.4 is solving ellipse. Now, ellipse, another way to look at an ellipse is just an oval shape. So this would be an example of what an ellipse is. So there's different parts of an ellipse that you need to know. The first part is the vertices. There are actually two. The first one is right there, and usually we refer to these as it's the furthest point away from 0. Okay. There's a second pair, and these are called the covertices. And the covertices are basically those points that are they are vertices, but they're the ones that are the closest to the center versus where the vertices are. And then the foci would be these 2 points. Okay? So when you graph this now, just like in a circle, the ellipse can actually move away from the center. We're just going to focus on ones that actually are in the center. Okay? Now, an example, if we actually, an ellipse can actually be turned upright. So then the only thing that changes is these right here are now called the vertices, and these are called the covertices. Okay, and the foci, which is on the same axis or the same line as the vertices. So the foci actually move from the x-axis in this case to the y-axis. Okay, the equation looks a lot like. One thing that you need to keep in mind about the equation, because we're going to talk about hyperbolas in the next lesson. And a hyperbola, the difference is this is going to be a minus, but you've got to make sure that they equal 1. Okay? And when you go to graph these things, it really depends on which number is larger. Okay? Is the A part larger or is the B part larger? It's going to depend upon how this thing lies. But the vertices and the covertices are going to be in the same spot. And all you're going to do is, since A lies underneath the x, then you're going to take the square root, and remember you get a plus or minus A, and your y is 0. So that'll give you the first vertice. When you're looking for underneath the B, since this one is B squared, that's going to be a plus or minus B, and it goes in the y spot. So that would give you 0. Okay? So it really depends on if A is larger, then it's going to be... So if A is larger than B, so if A is greater than B, then it's actually going to be an ellipse like this. Okay? If B is larger than A, then it's going to be an ellipse that lies along the y-axis. Okay? All right. So the foci, in order to find the foci, it's just going to be c squared equals a squared minus b squared. So you basically would subtract those. And remember, you needed to subtract the largest one minus the smaller one. And then take the square root, and that'll tell you the foci. Okay? So let's go ahead and graph one of these. So this is an example of what one would look like. We want to draw the ellipse given by x squared over 4 plus y squared over 25 equals 1. So really all you got to do is, since this one is underneath the x, you're going to take the square root of 4, which simply gives you plus or minus 2, and it's in the x spot. So the vertex is at 0, 0, so we're on the x-axis at 2, and we're going to do one at negative 2. And we're going to do the same thing with the y. So that's going to give us plus or minus 5, and this one is 0. So on the y-axis, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And there's what our graph would look like on an ellipse. Okay? And if you notice, the number underneath the y is the largest, so that's why these would be your vertices. Okay? Those would be your vertices. And since the 4 is a lot smaller, even though we graph it the same way, then those would be your covertices. Okay? All right. So go ahead and try example number 2. We want to graph the equation x squared over 16 plus y squared over 9 equals 1. Okay, so let's go ahead and do this. Remember, we're just going to do square root of that would give us 4. And since it's underneath the x, then I take the square root. Okay. And if you notice, we can look at this really quick and say, hey, this one's going to lay down long ways along the x-axis. Plot that point at 4. 1, 2, 3. Plot that one at -4. And because the number underneath the x is larger, those are going to be our vertices. So underneath the y, we're going to have our covertices. Okay. 1, 2, 3. 1, 2, 3. So there's what our ellipse is going to look like. Okay. All right. The second part of this is we just wanted to make sure that you knew how to write an equation. So when you're writing an equation, it says write an equation of the ellipse with a vertex of 0, 7 and a co-vertex of -6, 0. So when you're actually looking at this and doing this, I wouldn't get too hung up on the vertex or the co-vertex. What I would look at is, because you already know the center's at 0, 0, I would get more interested in where the 7's at and where the -6 is at. Okay? The rest of this is when you use your formula for an ellipse, since this is in the y spot, then I'm going to square 7, so 7 squared gives me 49, and put it under the y. Here, since this one's in the x spot, I'm going to put it underneath the x, -6 squared, which is going to give me 36, and I'm putting it above the x squared. And just make sure it equals 1. Okay? All right. So example number 2. Actually, it'll be example number 4. Same scenario. So since that one's in the y spot, that one's going to go underneath the y squared. And the 4 is in the x spot, so it goes underneath the x squared. So I'm going to end up with x squared. And so since 4's underneath the x, 4 squared gives me 16, plus y squared, and the 5, so I'm going to do 5 squared, which gives me 25. And that equals 1. Okay? All right, so go ahead and pause the video, and let's try to do example number 5 as a you try. And when you're finished, go ahead and restart the video. All right, so just like we did before, this one is in the x squared, so we're going to do x squared over 3. Oops, sorry, x squared, we've got to square the 3. 3 squared gives us the 9, plus, and then y squared, and we're going to square the -1, which gives us +1, equals 1. Now, just for cleanup purposes, remember, anytime we put anything over 1, we can write that as just y squared equals x squared over 9. Okay? And make sure it equals 1. Okay? All right. Well, that concludes ellipse. So go ahead and work on some practice problems and then do the quick check.